Welcome to the final solved problem on flitched or composite beams. The problem is stated as a flitched timber beam consists of two joists 100 mm wide and 300 mm deep with a steel plate 200 mm deep and 15 mm thick placed symmetrically in between and clamped to them. Calculate the total moment of resistance of the section if the allowable stress in the timber is 9 Newton per millimeter square. The given data and the parameter to be found out are first written as usual. We observe that the modular ratio, that is the ratio of Young's modulus for steel and timber, is not mentioned in the problem. Hence we specifically assume the same as 20. The composite beam section with the dimensions are drawn next. Let us now convert the beam with two materials to an equivalent single material for convenience of calculations. In the last problem, we converted the brass section to an equivalent steel section. So let's convert the steel section here to an equivalent timber or wood section. Conversion of steel to equivalent wood is also due to the fact that the value of allowable bending stress in wood is mentioned in the given data, while for steel it is not. Hence the steel plate is converted to an equivalent wooden plate of width equal to 15 times the modular ratio, that is 20, giving a value of 300 millimeters. We now draw the bending stress distribution diagram for the equivalent wood section with the maximum allowable bending stress of 9 megapascals applied to the outermost fibers of the wood as compared to the centroidal axis. By simple interpolation, it is easy to make out that the stress in the equivalent wooden section at the level of the steel plate is 6 megapascals. The section modulus for the equivalent wooden section for various parts is found out next. For the wooden section parts, the section modulus is found to be 3 times 10 to the power of 6 millimeter cube. For the part where the steel is converted to an equivalent wood, the section modulus is calculated as 2 times 10 to the power of 6 millimeter cube. The total moment of resistance for the section is given by the summation of the moment of resistances for these two parts, that is M equals M for wood plus M for steel converted to wood. This gives a value of 39 times 10 to the power of 6 Newton millimeters, which is 39 converted to kilonewton meter units. In the next lecture, we shall look at practice problems 11 to 13 on flitched or composite beams.